Are you ready for the engineer to bore you to death here with all the details of BMPs? So we are going to start here. We're going to talk about 7 different categories of BMPs. Each of these kind of has different configurations within them, so the palette is really endless to some extent. But these are kind of the general categories, and we'll go through them one by one. Amended soil, construction site soils, dispersion, bioretention, trees are BMP themselves, the best BMP really, because they're what nature gave us. Permeable pavements, vegetated roofs, and rainwater harvesting or reuse. So I'm going to start off with amended construction site soils. And actually, in a way, there's another term for it, which is post-construction soil quality, because you don't necessarily need to amend the soils. But the definition here, and you're going to see a similar pattern for each one of these BMPs. It's a soil or landscape system with adequate depth, permeability, and organic matter. Retains the native soil functionality in a post-development landscape. And the reason for this really is that when we develop conventional construction development, we'll destroy the soils. I mean, that's just a practical consideration for construction. You need to have a hard surface to run your equipment on. Your equipment's going to pound the soils. Oftentimes you'll just see them stripping topsoil and then just replanting at the end of construction. And what you'll see is those landscape surfaces start acting a lot like an impervious surface because they're compacted and they don't allow the water to actually naturally infiltrate, which is what happened before the development occurred. So this is really about restoring that natural function. So what does it do? It builds the soil structure, holds moisture capacity. Again, there's pore space within there that can hold water, quite a bit of water in fact. Increases the surface porosity. It can filter out the urban pollutants. So if you do have pollutant generating surfaces that drain to an amended soil or a native soil, it can actually provide that treatment. It reduces waste, yard waste, manure, biosolids is a way to kind of reuse some of those products in that area. And land clearing waste. Again, that's a lot of haul from a site oftentimes when you're doing that initial construction to strip away that topsoil and take it somewhere. So if you can keep it somehow on site, you can reduce that effort. You can reduce summer irrigation needs because again, the soil can hold the water and so you don't need to irrigate it quite as often because otherwise if it runs right off, you don't have it there available. I love this little slide because this is actually a study done years ago at University of Washington. Lawns with amended soils and unamended. And you can see here the top one is a non-amended soil, more of a conventional soil, and in the summertime it gets brown. It gets brown and does it, but the same irrigation conditions, same weather conditions, an amended soil immediately next to it is staying lush and green. So that's one of the great benefits of it. Also, because it's staying lush and green and the nutrients are within the soil, you're reducing the need for fertilizers and pesticides, reducing maintenance costs, and increases the regrowth of the protective canopy. So what are the applications? You could do it for all pervious areas on the site. If it's pervious, you generally should try to shoot for good construction quality soils. Incorporated designs into dispersion BMPs, so not only can it be just for mitigating the rainfall that falls directly on those pervious landscapes, but if you have room and it's adjacent to an impervious surface, you can direct that impervious surface into that area and get a really cheap BMP out of that, because that will help mitigate the runoff from that impervious surface. In the guidelines, there's some parameters. So if you have a non-turf or more of a just truly landscaping setting that's not meant to have foot traffic on it, the design goal is to have 6 to 8% organic matter content. If you have a turf application that's going to receive more foot traffic or other traffic, 3 to 5%, because then it's not quite as spongy and it's a little bit easier to use as a surface. And one comment I did get from Yakima actually is that maybe those are a little bit higher than what your native soils get. So there's some considerations there on what is the native soil organic content. So there's a lot of simple tests you can do to do that, but there's also, I'll go through it, there's some basic formulas that kind of get you to that organic content. Limitations of where you can't use this practice: steep slopes. Don't go and disturb them and go till them up if they're greater than 33%. That's going to create an erosion and perhaps a stability hazard. Imported topsoils themselves should not have excessive fines or clays within them because otherwise they're not going to provide that function that we're shooting for. Really, I'm going to go through 4 key options or strategies for achieving this standard. The first and most simple one is basically leave the native vegetation in place. Leave it undisturbed, protect it during construction, so make sure that the construction crews know that they're to protect those areas. So putting out orange fencing, having pre-construction meetings to say that we intend to protect this area is a very key element of this option. Option 2 is amending the existing topsoils. So if you keep the topsoil on site but it's not very high quality, you can actually bring in compost, or if you stripped away the topsoil and you're left with a native soil, you can bring in compost and till it into the soil to achieve the standard. And here's 2 basic formulas for that. to meet it for planting beds. 3 inches of compost tilled into 8 inches of soil will meet that standard. If you're going for a turf application, then you're allowed to just use 1.75 inches of compost and till that in. And prior to doing that, you scarify the subsoil to 12 inches of depth. So again, it doesn't have to incorporate the organic matter all the way through there, but that scarification again just expands how much porosity there is and gives the biota that's growing in that medium the ability to kind of extend the depth of that topsoil over time as it matures. Option 3 is to strip the site but keep the topsoil on site. And so you strip it, you very careful staging, and then you bring it back in. That can be a very easy technique and low-cost technique, but again, it depends on the site. If you've got a very constrained site, and oftentimes that's what we're dealing with in a development site, you're trying to maximize how much you're building, this can be a difficult one to do. And the fourth, and probably the least preferred, at least from the guidance, is to just import new topsoil. That's the most resource heavy because you're hauling away old topsoil and bringing in new topsoil. But again, if your site is limited in those techniques, then that can be a very simple technique to meet that, especially if you have just a little bit of topsoil to bring in, and bringing in the materials to till it in is more difficult than maybe just bringing in topsoil is an adequate technique. Then my next technique, dispersion, can take advantage of amended soils. If you have an amended soils, that's a way to kind of meet the dispersion techniques. Again, I think dispersion is one of those really low-cost, low-hanging fruit kind of techniques. If you have the space for it, why not? I mean, basically, the idea here is using the native landscape to provide that stormwater BMP. The definition is basically a vegetated area that collects runoff from adjacent impervious surfaces. Again, the idea is that it restores the natural drainage patterns. So oftentimes, if you don't have too much of an impervious surface going to the native soil can do the job. And there's 3 real basic types of dispersion techniques. There's concentrated flow dispersion, so taking something that's already been concentrated, piped, curbed, whatnot, and redispersing it, respreading that out into a sheet flow manner across a native or restored native type landscape to provide that infiltration and retention of that runoff. Sheet flow dispersion is basically keep it in sheet flow. So like this is most common in like a roadway application where you don't have a curve, a rural roadway where it just sheet flows off the road and goes into the adjacent vegetation. And then there's a technique called full dispersion, which is really if you have the appropriate ratio of impervious surface to pervious surface that you're dispersing to, then you can get credit and exemptions from all stormwater requirements. And that's really for a much more low density or rural type setting where you have that space available. So concentrated flow dispersion, it's to take runoff from, say, steep impervious surfaces that aren't really maintaining a sheet flow pattern, or if the impervious surface is steep enough, it's not going to remain sheet flow. It's going to find some rivulets and become concentrated. So you'll need to redisperse that. Driveways, sport courts, patios, and roofs without gutters, those are concentrated flows that can be redispersed. Single-family residential applications, again, rural areas. The idea here is really basically take that concentrated flow and you put it into a level spreader that's adjacent and it's long and it recreates that sheet flow pattern. It's very sensitive in construction to build those because they really have to be level and they can be notched so that you can spread that flow around. But again, if you have a landscape surface that either are native or amended soils, you could take advantage of that landscape as your stormwater BMP. And again, the benefits there are reducing peak flows and can have water quality benefits again because it's really kind of a long, flat bioretention type facility. Sheet flow dispersion, again, very similar, but basically just letting it stay in sheet flow across the native soils. This on the left here is a detail from the Eastern Washington LID manual. And the idea there is really keeping the sheet flow, but oftentimes you might still have a little gravel channel at the edge of your impervious surface to assure that you're still in a sheet flow manner. And then it goes directly to the adjacent native vegetation. Limitations on all that is that the slope of the native vegetation needs to be less than 8%. So you can't just be doing it to like a 33% slope or a road embankment. It needs to be generally flat because otherwise it's not going to remain in sheet flow. And it may also cause more hazards if it's on a steep slope. But again, you can get a lot of work done with a very narrow band of vegetation if you have the space for it. For full dispersion, this is really just more of a different category of that, which is that if you have a site that is less than 10% impervious and you have, say, 65% native vegetation around that site and you're dispersing it to that native vegetation, then you're considered to be okay for your stormwater requirements because that native vegetation, that ratio of native vegetation to impervious surface will essentially mitigate for that impact of the impervious surface. So like I said, the benefit of that is you can avoid triggering flow control. by leaving that natural vegetation on the site. It's primarily for new development, again, because existing development doesn't have those native soils in it. And you can kind of plan your site to achieve that goal. And sometimes it can be used for commercial and residential applications. Benefits of it, again, are the restoring the natural drainage patterns. Again, it's very cost effective. If you have a low density site, hey, why build stormwater BMPs if you could just thoughtfully design your site so that the runoff is dispersing and making use of those native areas. Again, there's not really much installation or maintenance required because it's really about a site planning exercise. And once it becomes native vegetation, there's not much you really need to do to maintain that. You just need to basically, if you do see problems, it's mostly because flow has somehow actually concentrated and is creating some erosion. Limitations, again, I just talked about it, steep slopes and landside hazards. You don't want to be dispersing runoff to those areas. Standard engineering practices are to keep the runoff away from those zones.